Chapter 4 review packet, page 6. We'll get some of the proofs now. So we'll go through number 13. We'll mark the diagram based on the givens and then what we can infer. So from the parallel, all right, those two vertical lines means parallel, MQ parallel. The markings should be arrows. That doesn't give us a pair of sides. And then what I traced was the backward Z, the inside corners there give us alternate interior angles. So that's one pair of angles congruent. We're going to use MT is in both triangles. So we're going to use that. And then they give us MQ congruent to MT. So we are going to then, because of this given, we're going to be able to put the slash there to get the other pair of sides. So it's going to be side angle side to get the triangles congruent. Okay, so go ahead and write that up. First, I'll just lump the givens together. So right now, you saw me cross off an S. We got an S there. Don't forget that. That should have a segment symbol up there. Sorry. All right. Now, so alternate interior angles theorem. That's debatable if that's acceptable or not. So I just put in there in parentheses, we've got to have a parallel lines. There is. So some teachers would prefer you say when lines are parallel, alternate interior angles are congruent. That's the theorem. So it really depends on your teacher's style, what they want. Just make sure you go with what they want. Okay, then we're going to go for the reflexive property. MT is in both, so that's going to give us an S, which is why we need to say it. So now the triangles are congruent by side angle side. Triangle congruence theorem. Okay, MN, this side, is congruent to TQ because the triangles are congruent. We call that corresponding parts of congruent triangles are congruent. I will allow again that abbreviation CPCTC. At the end, you'll see me write it again on this page. Okay, so for number 14, that was quick. AB and EB are given, so I mark those. Sides congruent. It's not an arrow, it's a slash because it's congruent sides. Angle D is congruent to angle C, and these vertical angles are congruent. It's not reflexive. They're opening up in different directions, so it's vertical angles. Now, the trick on this one is it doesn't tell us what triangles to prove congruent. We got to figure that out for ourselves. DB and CB are sides on these two triangles. So if I get these two triangles the same, those corresponding sides will be the same. I'll get the triangles the same by angle, angle, side. So we'll go through that process. It's good to name the triangles you're going to prove congruent, and the letters need to be in order, corresponding. So A has to match E, C has to match D, and so on. So it's good to take some time to make sure you write that out beforehand. All right, I'll lump the givens together again. That actually gives us a side and an angle right off the bat. The only one I've got to come up with on my own is the vertical angles, which I'm doing right now. Please don't just say vertical. Vertical angles are congruent. Write it out. Now we're going to say the triangles are congruent by angle, angle, side. And now DB is the same as CB by CPCTC. Again, what I require for my students is you can use this throughout the whole test as long as you write it somewhere on your test one time what it stands for. Corresponding parts of congruent triangles are congruent. All right, that's the end of page 6.